Today we are going to be solving more radical equations. And so let's take a look at our first problem. And this is going to be similar to some of the problems that you'll end up seeing where they give us the perimeter equals 16 centimeters. We've got a length here of 5 centimeters and a length here of x plus 1 centimeters. And what they want us to do is solve for x. And so since we'll say that this is a rectangle, and it doesn't show that, but I'll go ahead and say that it is. That means that we know what the other sides are. We know that the side opposite the 5 centimeter side has to also be 5 centimeters. And this one is x plus 1, the square root of x plus 1. So we know the perimeter is 16, so let's go ahead and set up a little formula. The perimeter of any kind of rectangle is just 2 times the length plus double the width. And so the reason we can do that is because the length is the same, 5 centimeters here, 5 centimeters here. So that's what we're going to go ahead and do. So we'll substitute some numbers in that we know. 16 is the perimeter. This all equals double the length, which is 5, plus double the width, which is the square root of x plus 1. So we go ahead and do some more work underneath inside our right-hand side of the expression. So we've got 2 times 5 is 10. Plus 2 times the square root of x plus 1. So we go ahead and subtract that 10 from all sides. And so we're left with 6 equals 2 times the square root of x plus 1. Well, we can go ahead and divide by this 2 now because we want to cancel that out to isolate this radical. But we got to do the same thing on both sides. So now we've got 3 equals the square root of x plus 1. Well, to get rid of a square root symbol, we're going to go ahead and square both sides. So I'm going to square this side here, and I'm also going to square this side. And so when I do that, I'm left with a 9 equals x plus 1. Well, I just have one more step there. Just have to subtract this 1 from all sides. And when I do that, I'm left with 8. And 8 equals x. So I always want to make sure that that answer makes sense. So I'm going to go ahead and substitute that 8 back into our equation up here. And so I've got 8 in for the x right here. So I'll go ahead and say 16 equals 2 times 5, which I know is 10, plus 2 times by the square root of 8 plus 1. And so when I do that work, I get 16 equals 10 plus 2 times by 3, because the square root, this is 8 plus 1 is 9, and the square root of 9 is 3. So go ahead and do some more work there. 10 plus 6, because 2 times 3 is 6, and those two numbers do equal 16. So it does check out. So I know this is correct, and the units would be in centimeters. So 8 centimeters is our answer. Now if they wanted to know the length of this side here, whatever that side was, we would say that x plus 1, I'm going to go ahead and put the 8 in for x, and then I end up with 9, which is 3. So 3 centimeters is the actual length of this side here. Well, the next problem deals with energy. So let's read what it says. An object velocity in meters per second is described by this formula here. Velocity equals the square root of 2 times the amount of kinetic energy in joules multiplied by its mass divided by its mass. And so we are given m is mass in kilograms, E is kinetic energy in joules, if the mass of an object is 5/10 of a kilogram. So we know that this number goes in for m. So we're going to put that number in for this m here and this m here. And the velocity is 40 meters per second. So we know that goes in place of v. They're saying find the kinetic energy, which is E. So let's go ahead and substitute what we know into the formula. 40 equals the square root of 2 times E, and then m. And m is 5/10. And then this is all over m, which is 5/10 again. So we go ahead and do some work there. We've got 40 equals, and then I'm going to multiply 2 times a half. So what I'm doing here is multiplying these two. I'm using that commutative property and combining these two terms right here, and that makes 1. So that's how I get 1. Oops, got The 1 inside is what I want it to do. So let's go ahead and write that square root symbol again. So 1 is what I got times e. So that's just e over this 0.5. Now let's get rid of that 0.5. And so what I'm going to do is I'm going to multiply by that 5/10 on both sides. So multiply by 5/10 here, multiply this by 5/10, and that gives me half of 40 is 20 equals the square root of just e. Now I'm going to get rid of that square root symbol the same way I did on the last problem. I'm going to use a squared symbol. I'm going to square both sides. And so that'll eliminate the square root symbol, so I'm just left with e equals, and then here I end up with 400. So let's just double check and make sure that answer makes sense. Let's go ahead and substitute that 400 back in for e here and see if it's 40. So 40 equals the square root of 2 times by 400, but I'm going to multiply by a half. And so when I take a half of 2, that just makes 1, and then divide it by a half. And so 40 equals the square root of 400 all over divided by a half. Well, the square root of 400 is 20. And so 20 divided by a half. So when I do this, a half, how many halves go into 20? Well, if I break 20 into halves, I'd be left with 40. And so we have 40 equals 40. So it does check out. So 400 is our answer. And this is in joules. So joules there. So, 400 joules. Well, looking at our last problem here, it talks about the equation equals v equals the square root of 2.5 times by r, where this describes the relationship between the radius in feet of an unbanked curve and the maximum velocity, v in miles per hour, that a car can go around the curve. So if the speed limit is 35 miles an hour, what is the radius of the unbanked curve? And so we've got some information here. 35 miles an hour, that's a velocity. So that's going to go in for v. And then they're going to ask for r because they're saying, what is the radius? So we're going to solve for that. So we got 35 equals the square root of 2.5 times by r. And so we're going to go ahead and or square both sides right now because we've already got this radical sign isolated. So we'll square both sides. So squaring 35 gives me 1,225, and this all equals 2 5/10 r. And so from this point, all I have to do is divide by 2 5/10 on both sides. So when I do that division, make sure again you're moving that decimal point over, adding a 0, so really it's 25 into this large number, 12,250. And when we do the division, we end up with 490 feet. Well, that's some distance there. That needs to be the radius of that unbanked curve. Well, those are the types of problems that you'll see on tonight's homework. Good luck.